Hi, this is Jeff Spence, your Math 135 instructor for the Community College of Denver. We're on to 7.3, which is our last section for the second exam. It's called the central limit theorem for proportions. Okay, so the last central limit theorem that we talked about was for means. Means come from quantitative data. When you have numbers, the easiest statistic you can take is the mean. Well, when you have qualitative data, the easiest statistic you can come up with is a proportion. So if I asked you guys where you were from, I can come up with a proportion, a relative frequency, proportion and relative frequency, same thing, for each place where you're from. Or when I asked you if you had a car or not, that's a yes or a no, and that we can come up with a proportion, a relative frequency, or a percentage, if you will. Okay. So anytime when we come up with a sample of qualitative data, keep in mind, we can come up with what's called the sample proportion. Sample proportion is titled P hat. P hat. So we say P hat for short, sample proportion. And the sample proportion is just X out of N. Remember, N is your sample size, and and X is the number who have that characteristic. Okay, so if I was talking about being from Denver or something, I would count the number of people from Denver. That'd be X divided by the total. It's just a relative frequency. Remember, a sample proportion is just a relative frequency. And the key thing about the sample proportion is that it estimates the population proportion that we denote by P. Okay, these are percentages. That's why we use P. Just like how X bar, the sample mean, estimates the population mean mu. Okay, so keep that in mind. So we're going to look at this statistic, the sample proportion as opposed to the sample mean, and there's a central limit theorem for that. So the central limit theorem for sample proportions, a sample proportion, is that the mean of the sample proportions is equal to the population proportion. That's just the same thing. I'm going to put this in red. This is very similar to the mean of the sample means being equal to the original mean, and then the standard deviation of the sample proportions is equal to the square root of P times 1 minus P over N. A little bit more complicated, but it's similar to the standard deviation of means equaling the old one divided by the square root of N. Okay, so we can use the central limit theorem, which gives us, it also gives us a normal curve. I forgot to put that down, a normal curve. It gives us the mean and the standard deviation as long as N times P is greater than 5 and N times 1 minus P is greater than 5. I don't know why I have 50 there. Let me erase that. It should be greater than 5. Okay, so we get to use this curve, or we get to use the normal functions, inverse norm and norm CDF, for proportions now to come up with probabilities. So let's do some examples on the next page. Okay, so let's take a look at this example here. It says that, suppose you're given this fact that 62% of all college students are female. All right, 62% of all college students are female, and you sample 100 CCD students. You want to find the probability that at least 70 of those 100 are female. So what this means, since 62% of all college students are female, that's the population proportion 0.62 P. Okay, that's not from the sample, that's the population proportion. Somebody told it to you, and we're going to accept that. Okay, then we also know that N is 100. So we're sampling 100 CCD students, and we want to find the probability that at least 70 are female. Now remember, from the central limit theorem, it tells us that the center of this P hats, the distribution, the mean which is the center, is always equal to P. In this case, that's 0.62. Alright, but the standard deviation of the P hats is the square root of P times 1 minus P over N, which is 100. Okay, so if we plug this in, P is 0.62. 0.62 times 1 minus 0.62, which is 0.38, over 100. You got to plug that into your calculator, and we will get 0.15 1535. 1535. So that's the standard deviation of this curve. So now we know the mean, which is 0.62, and the standard deviation, which goes, and the mean goes in the center. So we draw our curve. All right, draw the curve, and put 0.62 in the middle. That's our mean, 0.62. And we want to know at least 70 are female. Remember, that's at least 70 out of 100. So to do 70 out of 100, that's a sample proportion. So your p hat is going to be 70 out of 100, which is 0.70. 0.70 would go somewhere on the right, and since we said at least, we shade to the right, the probability of at least 70%. So we're looking for this area. All right, once again, once we're looking for the area, we do the z-score. So we do the observation, which is 70, or 0.70. So z equals 0.70 minus 0.62 over the standard deviation, which is 0.1535, and we get, I'm going to run out of room here, but 0.70 minus 0.62, enter, divided by 0.1535 is 0.5212. 0.5212. Okay? Then, to find that area, we do norm CDF and CDF of 0.5212 to E99. Plug that in, and we get the area to be equal to 0.3011, and that's our final answer. There's about a 30% chance that if of 62% of all students are female, that if we sample 100, that we'll get at least 70 are female. About a 30% chance. Okay, so you got to remember, usually when we see these problems, the first percentage that you're going to see, this first percentage, 62%, is the population percentage. I identified that. Then we tell you how many you sampled. Identify that. Once you know P and N, from there you can actually get your mean and your standard deviation. Okay. Lastly, when we ask for the probability of something, that tells you how to figure out your P hat. The 70 was out of the 100. 70 out of 100. So that's why I did the 70 out of 100, got 0.7. Since we said at least, I put 0.7 up there and shaded to the right. From there, once I have this picture, it's the same as all the other problems we've been doing. Do a z-score first. So the z-score for 0.7 was 0.5212, and then do the normal CDF to find your area. Okay, let's do one more example here. So the whole thing all over again. Okay, so suppose 30% of CCD students take the light rail. What does that tell us? That tells us what P is. We know that P is 0.30, which means from the central limit theorem, remember that the mean of the distribution, the center of this curve, is actually equal to that number. So we can say the mean of the P hats is equal to 0.30. That's kind of like the most likely outcome from what we sample. We would expect 30%, P hat sample of 30%. And then the standard, let's keep going. 30% take the light rail. If we sample 75 students, that tells us that N is 75. Oh boy, made a mistake there. 75. Okay, so then from there we can do the standard deviation of the P hats is the 0.30 times the 1 minus 0.30, which is 0.70 over 75. Plug that in, and you get 0.0529, which tells us that the standard error is about 5%. Okay, so usually with any estimate, you expect it to, on average, be about 5% away from the mean. Okay, so we need to draw a bell curve with our mean in the center, which is 0.30. Okay, and it says find the probability of at most 20 taking the light rail. Remember, this is 20 out of 75, so that's our P hat. We do P hat of 20 divided by 75, and we get 20 divided by 75. 0.26 repeating, so we'll call it 0.2667. Alright, so 0.2667 is on the left, 2667, And since it says at most, the probability at most, we want to shade to the left. So to find this area, we need to do a z-score. If we do a z, we get the observation, which is 2667, minus the mean, which is 0.30, divided by the standard deviation, which is 0.0529. 0.0529. Plug that in, and we get negative 0.6295. Okay, that's our z-score. So we got to find the area to the left of that. So we use NCDF from negative E99, negative E99 to negative 0.6295. That'll give us this area. So plug that in, and we get 0.2645. So about a 26% chance that at most 20 would take the light rail, or 20 or less, basically. Okay? So, central limit theorem for proportions is actually kind of interesting. We don't have a ton of work with proportions, and that's why this is harder. We actually do have a lot of work with means. We're used to means. But it's very similar, okay? We come up with a sample proportion when we ask a quantitative question. We do percentages, relative frequency, okay? And what we do with that is we use that to estimate P. Well, when we know P, we can come up with probabilities. So the mean, the center, the most likely, the expected value of the p-hats would be the population proportion. That's very similar to saying the expected value of the sample means is equal to the population mean. Then we also have the formula for the standard deviation, which we use in our z-score. From there, it's just a couple extra calculations of doing the standard deviation and the p-hat before you do your z-score. But the p-hat is your observation on the normal table. The mean is the center. From there, once we have the picture, we're doing the normal z-score normal CDF sequence. Okay, so you can see two examples here. Good luck. We'll see you in the future.